We talked about how if triangles are congruent, then all of the corresponding parts are congruent. Here we're going to talk about some shortcuts to prove that two triangles are congruent to each other. So we're going to prove triangle congruence, specifically SSS and SAS, and these are shortcuts. So instead of having to show all three angles and all three sides are congruent, we could get away with just showing 3 of the 6 are congruent. So these are shorter ways to prove triangles congruent. The first one is side-side-side congruence, or in short, it's called SSS. And it says if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. So basically here we have one side congruent to another side. We have another side congruent to another side, and a third side congruent to a third side. Therefore the triangles are congruent. So we say triangle GHI is congruent to triangle JKL. Here it's asking us whether triangle RTZ is congruent to triangle JKL. So we want to know if they're congruent. And they've given us coordinates, so let's map the coordinates. R is 2, 5. Z is 1, 1. And T is 5 and 2. So that's RTZ. And for the other one, L is at -3, 0. K is -7 and 1. J is -4, 4. So this is L, K, and J. What we want to do is basically we want to find the measure of each side. So first I want to do RT and compare it to JK. So RT is the square root of, so R and T, it's 5 minus 2, 3 squared, plus 2 minus 5, -3 squared. This is equal to the square root of 18. JK is equal to the square root of -4 plus 7, so it's 3 squared, plus 4 minus 1, 3 squared, the square root of 18. So this is both equal to 3 root 2. So we know that RT is congruent to JK. Next, we're going to do the other two. TZ, and then I'm going to do KL. So this is going to be the square root of 4 squared plus 1 squared, which is equal to the square root of 17. KL is going to be the square root of -7 plus 3, which is -4 squared, plus 1 minus 0, 1 squared, which is the square root of 17. So we know that TZ is congruent to KL. And next, I'm going to do RZ, which is the square root of -1 squared plus -4 squared is equal to the square root of 17. Same way, JL is -1 squared plus 4 squared is equal to the square root of 17. So these are congruent to each other. All right. Since we have 3 sides congruent to 3 sides here, we can say that triangle RTZ is congruent to triangle JKL because of SSS. So the next one is side angle side congruence. In short, we call it SAS. For this, what we need are 2 sides and the included angle of one triangle, and 2 sides and the included angle of a second triangle. So basically, here if I have one side, and here I have a second side that's congruent, the included angle is the angle in between the 2 sides. So included angle is the angle made by the 2 sides, so where the sides meet. So if 2 sides and the included angle are congruent, then we say triangle GHI is congruent to triangle JKL. So this is by SAS. We need 2 sides and the angle in between the 2 sides. So let's see here how the 2 triangles are congruent. We're either going to use SSS or SAS or neither. All right, so in this case, we have one side congruent to another side congruent to a side here, a third side congruent to a third side here. So here we have side, side, side. Here we have side, side, side. These 2 are congruent by SAS. In this case, I have an angle congruent to an angle, a second angle congruent, and a third pair of angles congruent. But because this is neither SAS nor SAS, it's just AAA, which doesn't exist, we say it's not possible to say that the triangles are congruent. Here I have a side that's congruent. I have another side that's being shared, which is congruent. The angle in between is congruent. This is clearly SAS. In the next case, I have a side, I have a second pair of sides, and a third pair of sides which is being shared, so it's SSS. And finally, here are some proofs. So here it says X is the midpoint of BD, meaning this and this are congruent. X is the midpoint of AC, meaning these 2 are congruent. So let me write that up. Midpoint of BD. X is midpoint of AC. I want to prove that the 2 triangles are congruent. So again, I'm either going to use SSS or SAS. Those are the 2 strategies that I have. I can see here that I have a pair of sides congruent. Here I have a second pair of sides congruent. Also, the angle in between is congruent. That makes it SAS. So since X is the midpoint, I can say that DX is congruent to BX. Also, CX is congruent to AX. This is the midpoint theorem. Next, these two angles are congruent, so angle AXD is congruent to angle BXC. Well, actually, I made a mistake here. It's not these two angles that I want. It's these two angles that I want, because I want to make this triangle congruent to that triangle. So it's angle CXD congruent to angle AXB. Vertical angle theorem. Now I can say triangle DXC is congruent to triangle BXA. SAS congruence. In this next one, we have AB congruent to CD and AB parallel to CD. Now, whenever you have two lines that are said to be parallel to each other, that's a clue for you to look for corresponding alternate interior and so on. We want to prove that AD is congruent to BC. So as a hint, whenever you have something like this, first you want to prove that the two triangles are congruent. So triangle DAB is congruent to triangle BCD. Okay, so AB is congruent to CD and AB is parallel to CD. Number 2, I have these two now as congruent sides. What I also want is to say that this side is being shared, so it's congruent. So BD is congruent to BD. Reflexive. So here we have a side that's congruent. Here we have a side that's congruent. This angle and this angle are alternate interior angles, so they're congruent. So angle ABD is congruent to angle CDB because of parallel lines, which implies alternate interior angles congruent. Next, now I can say triangle ABD is congruent to triangle CDB because of this gave us our A, so it's SAS congruence. And we know that if two triangles are congruent to each other, then all of their corresponding parts are congruent. So since the two triangles are congruent to each other, these sides which are within the triangles are congruent to each other. So AD is congruent to BC, CPCTC. So this homework for period C will be due Monday, which is the 9th. And there is a quiz for period C Thursday on the 6th, on the 5th.